Всем привет! С вами подкаст «Подлодка». Сегодня у нас снова уже второй выпуск на английском языке. Сначала представлю наших ведущих. Сегодня в эфире Женя Котелло, это я, Катя.
Всем привет и заранее извиняюсь за мой рунглиш.
И Егор.
Всем привет, а я извиняться не буду, потому что нечего стесняться.
Бесполезно просто.
Это правда.
Правильно. Ладно, чтобы не заставлять гостя ждать, переключимся на английский. Okay, now we start speaking in English. And let me introduce our honorable guest. Today we have in our virtual studio, I'll try to do it in both Russian and in wannabe Danish pronunciation. We have Björn Straustrup or Bjarne Straustrup.
Something like that.
I tried.
Pretty good.
I did my best. Okay.
Yeah.
Bjarne is a technical fellow and managing director in the technology division of Morgan Stanley in New York City and a visiting professor in computer science at Columbia University. But he is best known as a creator of C++ programming language. Bjarne, hi, and it's really nice to meet you here.
Nice to be here. Thanks.
So let us start with some really common question we ask everyone who comes to our podcast. Actually, what is your background? Tell a little bit more about yourself. How did you came up creating C++?
Well, I was born in Aarhus, Denmark. Was educated at the University of Aarhus in Denmark, and then after my master's, I went to England and studied computer science at the University of Cambridge. And after that, I got a job at Bell Labs in New Jersey, in the United States, in the Computer Science Research Center. That's where Unix was born, and C was born, and a lot of other things. A lot of communication stuff, of course. A lot of theoretical computer science too. And I realized I had to do something reasonably well to feel at home there, because everybody was doing great things. And I decided that I was going to write possibly the first distributed Unix system. That is something that could run on multiple computers or multiple processors. That was in 1979. And I got a little ways into that project when I realized I couldn't do it. And one of the reasons I couldn't do it was that I didn't have any tools that would help me for things that was critically difficult. In particular, I needed a language that could do really low-level stuff. Stuff like device drivers, process schedulers, memory managers, network connections, and that kind of stuff. On the other hand, the languages that could do that couldn't do my high-level stuff. If you wanted a distributed system, you had to be able to say this part of the system is over here and this part of the system is over there, and they talk through this particular protocol and set of rules. So low-level facilities like pointers and bytes and such gets in the way of separating and organizing things. So I needed a language that could do both. And there was lots of languages that could do either. High-level languages, low-level languages. And so in the end, I took ideas from C, which I built on, and ideas from Simula, basically the classes and the coroutines and the class hierarchies, and put them into C so that they could run fast enough to be useful for sort of systems programming, which the higher level languages with abstraction facilities couldn't at the time. And that was sort of the birth of the idea of C++. And so I built this, and this turned out to be useful. I had my first user that worked doing language research after 6 months, and I got more users, and I got more busy improving this language as it was growing to become. And So it was called C with classes for a while. Then we had to rename it C++, and eventually it became available. In the process, of course, I got so busy that I never got to write that system. So I missed the opportunity to build the first Unix cluster, but that was probably good.
Okay. And I think we'll come back to C++ a bit later. Now, I'd like to speak about languages in general and just maybe about your experience, or maybe you've noticed some interesting things. And the first question is, have you, as a creator of one of the most successful languages in history, I presume, have you noticed any consistent patterns in languages development, especially some patterns that can determine if the language is going to become successful or not? Maybe some core decisions made by language designers. What can determine successfulness of a language?
I don't actually think it has much to do with language features. It has a lot to do with a designer trying to solve a real problem. A lot of languages are created because people sort of think they can do something better than others, or because they want to write a paper, or because it's cool to write a language. All the most successful languages, as far as I can see, came because somebody had a problem that needed solving. And that's the way you can look at things like JavaScript and C++ and Python and such. The common pattern is that somebody set out to solve a problem. And then that somebody has to understand the application area as well as the language technical things. Initially, these languages are somewhat flawed from a technical point of view and from the fashions of the day, but that's less important than having the right problem and a good general solution to a class of problems.
Mm-hmm. It actually brings me to the next question. So C++ was created 35 years ago, and back in those days, I think problems were different than today's problems. So what are the particular reasons why C++ is still very highly adopted in the developers community? Why so many developers still use it?
Actually, I started more than 40 years ago. The 35 years, the commercial release, after just 5 years of mostly me building it. I think the reason it's so successful is that it addresses two needs. It addresses the need to squeeze a lot of performance out of the hardware, using the hardware well, and the need to abstract from the hardware and reach the level where humans think. Basically adapting the language to an application area, a problem. And so the two things, good hardware access, good abstraction, is what it does. And very few languages does both. They decide, well, we can do without all of that low-level stuff. And then C++ runs 10 times faster when somebody tunes it. Or they say, well, you don't need all that high-level complicated stuff. We can do with low-level stuff. And then when people need more abstraction or more scale, need to organize larger code bases, then C++ wins again. And what I just said doesn't seem to have changed over the last 40 years. There are things that needs both abstraction and performance. People say the machines are getting faster. They did for about 30 years. Now they're not getting any faster, but our demands of them are growing. And that puts pressure on performance, efficiency, use of hardware, energy consumption of hardware, all of that kind of stuff. So people still need the performance aspects of it. And as we're making more and more complicated systems, we need the abstraction mechanisms more than ever. The only thing I know that grows faster than computer performance is human expectation. We always want more, and we want it cheaper.
Yeah, actually, it perfectly matches with my own experience because here at Yandex, where I work, we have a lot of code written in C++. But whenever we start some new project, some like internal startup at Yandex, usually it's written in some other languages, some more easy to start with, like Python or maybe Go or any other. But eventually it comes up to rewriting the whole core to C++ because we want to have some economy on the amount of servers and all this stuff. So it looks like a normal life cycle of a system to come to C++ to achieve the maximal performance, I think.
I think so too. It's a matter of scale. If you just have a small problem for one person on one computer, fine, you can use any language you like. If you have 100,000 or 1 million users, then you start. Yeah, you can do it if you have enough computers, but then you can't afford the energy bill or the warehouse bill. And so you start thinking about performance, about efficiency of various sorts. I was once told by somebody high up in Google, somewhat aggressively, that they only use C++ because nothing else would do it. And I sort of slightly startled, but after a second or two, I said, yeah, thank you. That's the highest praise.
I have a question about Start, but not a project, but a profession, your development in profession. Despite highly adaptation, there is a common opinion that C++ is not the best way to start programming, and there is even a joke, or maybe not a joke, that some students in IT, they are leaving their profession and change specialization because they're scared about their code labs, first labs in C++. Why do you think
the story of my life?
Well, it is more difficult. And I think there's two things we should take into account. I think people are making a huge mistake when they try and teach computer science, IT in the same way to everybody. There's no other fields we do that in. I think we have to distinguish between sort of fairly casual users and the close to engineering level of knowledge that it takes to build our infrastructure and our harder tasks. And if you take somebody who thinks computing is doing a little web app and put them into an engineering course that requires understanding of the hardware and your data structures and algorithms, they get really they don't get what they want. A lot of people want to see results next week when they start writing code, and there's people that encourages that view. We don't encourage people who wants to be physicists or mathematicians to be able to do world-class work next week or next year. And some people tend to encourage young people, students, that next year they can write the game that will make them rich. This just doesn't happen very often. And if you come in with that attitude and you're then supposed to build the system on which lives and livelihoods depend, things that controls aeroplanes, things that controls telecommunications and such, they need a different set of expectations, a very different education. And when you've got the mismatch, if you get the mismatch between what people expect and what people have to deliver, that's when you get the problem. I actually did teach C++ as a first language for a few years. I was a professor at Texas A&M for a few years, and somebody got me to teach the introductory programming course for the engineers, electrical engineers, computer engineers. And I tried to do it the classical way, using the standard textbook, and it basically didn't work. I was walking around after reviewing 20 textbooks and screaming, well, if that's C++, I don't like it either. Because it was presented truly awfully. I mean, scary. And so I wrote my own book, which you may have seen. It's one with swans on it, programming using C++, principles and practice. And you have to approach a language appropriately for what it's supposed to be used as. There's not just one language for everybody, and there's not just one kind of programmer for every system.
Okay.
And what do you think of languages like Rust, maybe that are so-called C++ killers that also provide the same speed, but also some advantages for simpler programming?
Have you noticed that most languages in the last 30 years were going to kill C++ very soon, and they were going to run just as fast, and they were much easier to use? And C++ is still here, and there's more C++ programmers than there ever were. About 4.5, maybe 5 million of us. When Java came out and it was promised it would absolutely kill C++ in 2 years. That was High Sun Executive in 1996. We're still here. There's room for lots of languages. I mean, it's nice to see Rust picking up some of the ideas for C++, to the point where I sometimes get accused for having borrowed from Rust, things I invented 30 years ago. So let's see what happens. It might become a nice language. It might become a very useful language, but let's see. C++ has been here for a while. Many people have tried to put it out of business. And you know, if something comes along that really is genuinely better for most or almost all things, good luck for that. It would be nice, wouldn't it?
Yeah.
But it hasn't happened yet.
Yeah, and my bet is that 40 years from now, C++ will still be in the game. So I'm pretty much sure about that.
I wouldn't be surprised. I was once asked whether in 50 years our programs would be written in C++ or by robots. And I said, I don't know, but I have an idea how the robots are going to be programmed.
Okay, and one more question about the performance issues, but a little bit more wide approach. So these days it's quite popular to leave the performance for later days. So now let's do something that works now, and then we'll optimize the performance. And actually modern technologies and modern languages, they actually encourage developers to write non-efficient code because it should be easier to start. How do you think, is it a normal situation, and how actually did we get here?
This is a difficult issue. It's obviously right that you shouldn't optimize really early on. On the other hand, you shouldn't make decisions that can't be optimized in the long run. So quite often, getting things to run fast means that people don't look at their data structures, they don't look at their algorithms, they thoroughly ignore hardware issues, and they come up with something that basically has to be rewritten from scratch if you want it to run fast. That's not a great idea. On the other hand, you shouldn't sort of optimize from the beginning because you don't know what you're optimizing for. And so I see too many people in C++ starting out with really low-level stuff because they think they need performance. And just as I see people using languages so that they can't optimize in the end. So how do we get to sort of a middle point where it actually works? And I try to have my designs as high level as possible. And then keeping an eye on Don't get a squared algorithm in, and a lot of indirections that are dynamic so they can't be optimized away. Looking at how you represent things, how you do your algorithms fairly early on, that could be seen as optimizing, but it's not really. It's just organizing your thoughts well. And then later you measure the stuff and you see where the problems are, and then you tune. One of the things that C++ is really, really good at is being tuned. If you find an algorithm and a data structure that is crucial, you can usually optimize the way it's implemented so that you get better cache performance, better branch prediction. You can use special purpose hardware. All of these kind of things can be done. And I refer to that as the onion principle. That is, you start at the outer level of the onion and things are fine, it's fairly easy, it's quite elegant. And if you want to get more control, fiddle more with the details, you peel off a layer of the onion. And you keep doing that till it's fast enough. But you know, with onions, each time you peel off a layer, you cry more. Because it gets more complicated, more difficult, you make more mistakes. That's why I call it the onion principle. You don't actually peel unless you have to.
It's a very good metaphor.
And you finish with assembler injections and a lot of tears.
Yes, I mean, I spent a couple of years doing microprogramming for a living, and well, it's pretty hard down there, but you can do amazing things. And I mean, from C++, you can keep optimizing till it runs on an FPGA. So but you don't want to unless you have to.
Okay, and also, what do you think about the modern languages which use this idea of being really easily adopted even by people new to programming who doesn't have a lot of years of experience, like Go, for example. So everyone can start. It has a simple learning curve, and everyone can start with it without making horrible mistakes. Is it?
That's for some definition of everyone.
Yeah, probably.
It's already sort of well over towards the engineering end of things. If you look at all the people in the world, most of them couldn't handle any of the languages. They can do Logo, and maybe they can get started with Python or something like that, but not Go or Rust or Kotlin or C or C++. People who think C is a simple language are in for a surprise if they want to actually use it. There are, of course, people that should use the easier languages. It's just I don't think Go belongs in that category. There are these languages that allow you to set up a website. There's languages for children to move little characters around on a screen and such. These are great for that kind of stuff. But I don't want anybody to program the brakes of my car in such a language. Nor do I want people who had only known such a language to program something like the brakes or a medical monitor or something like that.
Yeah, it's fair enough, I think. And actually, next question is coming from this one. It's about, I'll call it a portrait of a software engineer. So back in the days when you were creating C++, there were a range of problems solved by software engineers. Now the problems are different. How do you think, how actually the skills and the mindset of software engineer changed through this time?
How are the problems different?
I think now we have to be able to run things faster, to test our ideas, check if we're doing right thing, and then to just rethink everything from scratch.
Yeah. Agile idea of global agile of the world.
Yeah, well, I know friends who says they are so busy doing agile that they can never get any work done.
It's very funny.
We have always tried to squeeze more stuff out of the hardware. We have always tried to deliver stuff faster. What is different, if anything, is the scale. We have to deliver bigger systems to more people, but we do it by having more programmers and far better tools. And I think some of the fundamental things haven't changed all that much.
Actually, that's why I'm interested in this question. That today there are a lot of discussions over the internet about, do the modern developer need to know basic algorithms? And many people are speaking like, I don't need to know how exactly to implement this sorting algorithm. If I'll need it, I can just Google it. And I think that back in 80s, probably, engineers were a lot more into some fundamental computer science knowledges. Is it correct?
That's probably true. And the best software engineers today still are. We use more tools, though. And the people who sort of despise the fundamental knowledge probably shouldn't be called engineers. There's a lot of software engineers that wouldn't get their foot into an engineering school. And as I said, I would rather not have them involved in something that's really critical to my life or livelihood. And it's just there's a larger scale of things, and there's a lot of things that can break without many problems. The part of the software world and computer world that I'm involved in is exactly the one where things are critical. And if your little website crashes, that's not my problem. That's fine. Now, the bigger applications, Facebook, Google, Yandex, things like that, at the bottom of these systems is an engineering layer that's lying in between the sort of application software and the hardware. And that's the kind of stuff I'm interested in. Maybe 10-15% of developers, 10-15% of the work done. But you know, if you are down at that level, if you do communication, you have to know something about signal processing. I think that there's still that level of expertise and that level of competence and domain knowledge that we critically rely on. Even if people on the web never met anybody and just take for granted that their phone works and I can talk to you from New York to Moscow. We're just sitting here chatting. The hard part of that stuff is hard engineering. Hasn't changed.
Yeah, I can agree.
And maybe another thing that have changed is how we are concentrating now at soft skills. Another joke that we're hiring for hard skills but firing for soft skills. And it's true. I think it's really true. But what do you think if the situation have changed during last year, or it's just because we are always discussing all things and also soft skills?
Communication skills have always been absolutely critical to be a good developer. You have to be able to understand problems. You have to be able to interact with people you're solving problems for. You have to understand those problems, and then you have to communicate your solutions. So the best software developers has always been good communicators, people with a certain amount of empathy. The caricatures, of course, didn't fit that. I think the caricatures have changed a fair bit, but the reality, the people that build the systems that actually work, the people that does the analysis of what is to be built, hasn't changed that much. As the teams grew larger, of course, that becomes more critical, but they're always too large for anybody to not communicate.
Mm-hmm. And talking about skills, how do you think, what are the most important skills and areas of knowledge that can help us determine what kind of person could be proudly called a software engineer?
Yeah, that's hard. Let's go try and sneak up on that answer. I think probably the most important skills in the field is the ability to listen, the ability to express yourself clearly, the ability to learn new stuff. This is very, very general, but I think it's key. And then you look at what are you actually trying to do. If you're doing hard engineering stuff, you better brush up on your math and your engineering skills and your physics and such, and that takes years. So you have to look at people who has the hard domain knowledge there, and then also ability to do what we said first: listen, communicate, learn. And now, once you try to apply this, you need at least a team that has some of those sort of hard science engineering skills, and then an understanding of an area. If you're doing, say, biology, you now need the knowledge of biology, and you probably need some graphics too, because otherwise you can't see what you're doing, quite literally, because you can't see the biology. Or it could be history or something like that. So quite often you have the personality traits, the sort of the skills you got in university and the fundamental stuff, and then you have an application area. It's very rare to have a person who has all of that. And it's even rarer that a person have everything that they'll need during a career. I mean, if you switch, you have an application that involves biology, then you have an application that involves history. The likelihood that you know both is about zero. If you also need the engineering skills underneath it, you're very, very close to zero. And so you need teams for that, and you need to be able to communicate within the teams, because there will be specialists. One of the things that I think has changed, I may have sounded as if I didn't think anything had changed, but that's absolutely not true. One of the things that has changed is that a lot of us are more specialized. And so to put together something fairly big, say again, you need specialization in various fields: storytelling, graphical presentation, distributed computing, etc., etc. Since we can't have that as an individual, we need a team, and we need some organizational skills and all of that kind of stuff.
Mm-hmm. Okay, thanks. It sounds just really extensive description of skills needed for the developer. Okay, and
by the way, what I did not answer was how do you actually determine if somebody's got it? And the only way I know how to do that is to talk to people and see their work and such. The idea of having to decide whether somebody is good by asking them to write some code on a whiteboard is really scary, because I think it's so error prone.
Yeah, totally. But still we're doing it more and more.
Yeah, I know. That's why I mentioned it.
And actually about whiteboard interviews, I presume you've done a lot of job interviews with some candidates during your career?
Not that many. Most of the interviews have been at a sort of a fairly high level. Somebody who wanted a job as a professor or somebody wanting a job as a researcher at Bell Labs. And there people have they have a bio, they have a track record. I can start by reading some of their technical papers and look at the systems they've built before I even see them. And so I can be pretty sure of the basic skills before I even invite them to an interview. And that means that the interviews sort of tend to focus on what part of those things did they really do themselves, because people sometimes exaggerate a bit, and also looking for the soft skills, as you mentioned earlier, Kate. And can they talk? Can they explain themselves? Can they understand a new problem? How do they sort of behave with other people? I've never been able to work with people I couldn't trust. Wouldn't work in a place where I had to watch my back all the time. And so I wouldn't hire such people. And so I assume they can do the technical stuff before they enter the room.
Maybe you could share with us one such behavioral question which you ask your candidates.
I don't have a standard set of questions. It depends on what the CV said and what are we trying to do. One of the old things is that for research, which is my main concern here, and for teaching, you sort of look at, is this somebody with one skill and only one skill? You can see people with a stellar track record, but they've only kept doing one thing over and over again. And that doesn't feel right. So one question could be, well, if you couldn't do that, what else would you do? That actually happened to me once when I was trying to get into Cambridge for a PhD. And I was talking about one field, and halfway through they said, that's not usually very successful. Is there anything else you can do? So I switched gears and talked a lot about machine design and microprogramming. That worked. So I look for breadth in a person, not just over-specialization. We have to specialize, but hey, maybe we have to change a bit over the years.
Mm-hmm. And talking about the signals from the interview, what are the red flags for you that you definitely need to reject this candidate? Anything
Arrogance.
Except arrogance. Okay. And maybe
they might be the best developer, but they will spoil a team.
Maybe anything else?
As I said, I probably know before the interview. This is different because of my situation and such, but I probably know in advance that they're technically competent. So that is taken as a prerequisite. If I couldn't take it as a prerequisite, I would be digging very hard to try and figure out whether the basics were sound.
Okay, that sounds really great, because it sounds like you're doing some big amount of job before actually starting the interview with the candidate.
Oh yes. It also means that I'm not actually doing a lot of this. Mm-hmm. That is, I'm talking about being involved in recruiting with several other people, of looking at a couple of dozen people a year. People in HR departments and people who want to staff up a company with 200 new programmers simply can't do this. But I don't have much experience in that, so I'm not going to talk about it.
Okay.
Previously, you mentioned that coding at the whiteboard is a bit harmful and error-prone. And what other interviewing practices do you consider good or maybe bad? How to understand if a person can program well, if you don't have these records?
As I said, I don't have much experience with that kind of interview, and I'm sort of loath to talking about things I don't understand very well. One thing I worry about with the whiteboard interviews is that we don't really write code at the whiteboard. We interact with our computers and our tools and such. And we do go to Google and Reddit and things like that for information. And we have sources for doing it. These interviews tend to be focusing on fairly simple, fairly standardized problems. And those are not the real problem. That's why I'm worried about it. Now, you asked what would I do instead, and I sort of refuse to answer for lack of experience.
Okay. And let's get a bit more about you then, about the industry itself. And actually, next question will be about your role at C++ now. What actually is your role these days in C++ development?
I'm never quite sure what my role is. I try to look at the technical issues we're dealing with, and so in the standards committee, I spend a lot of time in the evolution group. We look at new proposals. We look at proposals being processed. Concepts were a major thing that I was doing for years. Modules is a very interesting things. Coroutines, lambdas, you name it. They're technical specifics. What I try to do that's probably a bit more unusual is I'm actually trying to think about what's the language as a whole, as opposed to looking at the technical details or a specific proposal. That's what most people do, and that's what's easiest. But trying to figure out what are we really trying to do? What will help the community over the next 10, 15 years, as opposed to what will help me in the next year. A lot of people have a really hard time thinking about big questions like that. What's fashionable and a fad, and what is solving a genuine problem? What are the kind of problems we want to solve? Where is C++ supposed to be strengthened, as opposed to just trying to compete with some other language that can do it really well? I have no wish to branch into fields that are already well covered by other languages or tools. And so I try to think about the big question.
So we can say you are something like product manager for C++.
It's more philosophical than that. We're thinking about direction and roughly which way should we go. One problem is most people have very little experience with setting direction. They work for a firm or a university, and they're told roughly what kind of things they're supposed to do. And they're very good at executing given a specific task. Just like in universities, we tend very often to be really good at solving specific questions with a correct answer. There are no one correct answer for most of the things we're dealing with in language design. You have to guess what problems people will have in 5-10 years. You will guess what kind of tools they will have to help them deal with it. And then we have to decide where to spend our limited resources in getting in that direction. So I talk a lot about direction. We want to go roughly over there. And then we want to take steps to get there, but small steps so that we can get feedback. I mean, without feedback, it's not engineering, it's just guessing.
Oh, okay. And you mentioned standardization committees and all this stuff, and actually I had a question about that. When actually, and how did it actually happen that when you started to develop C++ as a language, not just on your own, but with some kind of committee? When did it happen? And was it hard for you, probably emotionally, to let it go and stop being the only person responsible for the language and start sharing this responsibility with other persons? with other people?
Sure.
I mean,
let me first point out that throughout all of this, there's also been other things that I have to do to be able to function. One is I have to think about teaching. How do I get ideas across? So I have that's one thing. Then I have to go and see a broad spectrum of users. There's so many kinds of people using C++ in so many ways, and so without travel and talking to a lot of people, I'll be flying blind. And then finally I have to keep writing code, because otherwise I could just dream up solutions to problems that didn't matter or overlook the problems. Anyway, so how did we get into standardization? I didn't really have a choice. In I think it was in the spring of 1989, representatives from HP, Sun and IBM turned up in my office at Bell Labs and basically told me that I really wanted to help them standardize C++ under the ISO rules. And of course I said, no, it's not ready, I'm still experimenting, this is not finished, it's not ready. And they say, well, you really want to do this, because otherwise we'll do it ourselves and you can do it better. So it's very flattening, but it's not ready, we are not finished, I need to experiment, I need to build more. No, you don't get it, Bjarne, they say. Our corporations were the biggest corporations in the US in the computer industry, cannot rely on a tool they have no control over. They cannot rely on a tool that is owned by a corporation that might become a competitor. So we really need a standard. Of course, we'll trust you, but you might get run over by a bus. Whoop. They actually said that. So in the end, after an hour's discussion, I agreed that we needed to standardize C++ under the ISO rules. There was other rules, but I wasn't really given a choice. And so you have to make the best out of it, and I think we have made actually very good things out of it over the years. And we can have people collaborate, people from competing organizations, people from many different languages, including Russia, turning up to the meetings and contributing. It's not easy. We had 252 people at the Prague meeting 3 weeks ago. And how do you get 252 people to agree on anything? This is not easy. The different industries, different countries, different educational background, different time constraints. Very difficult. But so far we have managed. We have managed since the first meeting, which was in 1990. And so it's 30 years and the language is still thriving. And it's a better approximation to my original ideals that it was in the beginning. And I think there has been a fair bit of continuity. If you look back in my writings from the early 80s, and especially to the book I wrote in 1994, The Design and Evolution of C++, C++20 looks remarkably like it. I mean, people saying, well, you didn't think about generic programming. So, well, I wrote a paper in 1980 that said we needed to do it. I just got it wrong how. I said macros and it didn't work, but I had the right problem. And only with concepts introduced now does it actually do what I wanted it to do. And you can read Design and Evolution of C++. It mentioned things like auto, it mentions the onion principle that I mentioned before. It has a 3-page apology for not doing concepts. I didn't know how. So there's a lot of stuff that's only just coming into play now. I mentioned modules. I was bemoaning the lack of coroutines. I had them for 10 years and I lost them. to implementation problems. Yeah. But standardization has been good to C++. It's been essential.
It sounds amazing, because we have this discussion in one of our episodes about programming languages, that many programming languages came up with some ideas that have been described in papers back in 70s or 80s. And just now, these days, maybe 10 years ago, some of these ideas were actually implemented in languages. And it sounds like you actually did both parts of the job in C++, because you both made some ideas back in 90s, and then it's implemented these days.
Yeah, I can be stubborn and work for a long time. There's a conference in London in June, the History of Programming Languages conference. And that conference happens regularly every 15 years. So this is the fourth History of Programming Languages conference. And in the Hubble 2, the second History of Programming Languages conference, C++ was the youngest language, and I presented it. I presented it again 15 years later, and I'm going to present it again this June. So I'll be the first one to give 3 lectures at that conference, and the only such. And C++ will be the first and only language to be presented 3 times.
Yeah, that's remarkable. And one more question back in history. Every, I think, rock star is being asked, when did you wake up and understand that you're famous now? And I have just the same question to you about the C++. When actually did you wake up famous, and when did you understand that C++ is now a widespread language which is used by a lot of developers around the world?
I think sometimes in the 80s, I don't quite know when, because I was very, very busy at the time. I was writing compilers, I was designing the language, I was teaching, I was writing research papers, I was bringing up a family, and it was the late 80s was sort of a blur. And I think when I recovered from that, I realized the 2 things that you've said, but I was very slow. It probably took me 5 years to realize, because I was busy.
Okay, so
I was also the help desk, and writing libraries. There was just so much.
So you didn't wake up once, you were waking up for 5 years to understand that you're famous now.
Yeah, sort of. I think it slowly dawned on me over the years, but I don't remember the details.
Okay, and just a couple of different questions about all the other stuff. In recruitment, sometimes there are some awkward situations when people get job offers about technologies that are totally mismatched their profile. For example, Java developers get job offers for JavaScript or all these kinds of situations. Have you ever got some invitations to get a job for a C++ developer?
I've gotten a lot of job offers, and I'm pretty good at turning them down. If you look at my career, I don't change jobs very often. I think I've done it. I'm on my 3rd big job, right? So yeah, it happens. There's people who want me to write code because they think I'm good at it, and there's people who want me to manage large teams because they think I'm good at it, or give legal advice, or I don't know. I'm pretty good at saying no when I know I can't do it.
I just can't imagine you receiving the invitation for a job interview regarding the cool office somewhere in downtown, nice chairs, nice conditions, young and very proactive team.
It happens. It happens every year.
It sounds like it happens to you and to the best of us.
Yes, it just happens. That, and then the executive jobs also, which I turned down with the same kind of quick response.
Okay.
It's just not me.
During our record, we sent a screenshot with our faces to our chat with our listeners, just like a teaser. And they were very surprised and excited, and they are waiting for this interview so much. So maybe you can wish something to our audience. They're engineers from different kind of spheres. They're using different programming languages and C++, of course, also. So maybe just a few words to our audience.
What on earth do I say to that? Do something good. Be professional. Be sure that you're actually doing something that makes a difference.
Nice, thank you.
Okay, and actually one more question for you. What languages do you use yourself these days? I mean, except C++, of course.
I usually dodge that question.
Oh.
Because it always gets sort of taken out of context. So I use C++, I use other languages, but mostly it's C++.
Okay, sure, it's totally accepted.
Sorry, it's just I just have a lot of experience with having my answers verbally or in writing taken out of context, and strange things happen. And that question is one that I've seen misused a few times, so I dodge it.
Oh, okay.
At least I'm willing to say that I dodge it.
Okay, sure. And
yeah, I read about fail interview, which was not yours, not your words, about that C++ was invented like complex language just to increase salaries of programmers. And
I've read.
It's awful
thing. I've read that paper. It's 30 years old or something like that, and it was wrong when it started. I think my best comment was after reading it, I thought, no, if I'd written that, it would have been funny.
Okay, and
you can find humorous papers by me on the web. So I can back up that statement.
Okay, but just to be clear, we're not going to cut anything from this interview. It's going to be published just the way it happened. So,
sure.
Yeah.
Maybe just our language. Maybe.
Okay, and one last question from me. There are many books called Learn C++ in 21 days. So now it is the time to know the ultimate answer. How many days does a person need to learn C++?
Depends on the person, depends on what they mean by learning it. If you want to be a really solid developer, you can spend 4 years getting a bachelor's in computer science, another year or two to get a master's, and having done that, you can learn to do C++ really well in only a few months. Now, if you already have a background and you already can write code and you know a little bit about how to write a for loop and how to run a test. I wrote a book called A Tour of C++, that's now in the 2nd edition, and that can give you a start with C++ in a weekend. I know that because it's done. People can do it. It's 200 pages. It will not tell you how to make an invariant or write a for loop. It'll tell you how you get that idea out in C++. And so we stretch from about 8 years to get there to 2 days. And people, depending on their backgrounds and their needs, are in between there. If you are a first-year student, good first-year student in a university with a teacher, in about 3 months, 14 weeks, you can work with the Swan book I mentioned earlier and be ready for your first project under supervision. It works. I've done it with thousands of students. I used the tour, by the way, with my graduate and final year undergrads. They get 2 weeks to read it, because they are not actually experienced developers yet, so it's not the 2-day, it's the 2-week. But you can do that as a good computer science student. And there's so many skills. I mean, I'm writing a paper now using LaTeX, and I'm getting this impression that if they think C++ is complicated, how can you survive with LaTeX? And same with our operating systems, same with our application areas. I think if you approach it correctly, C++ is not the problem. It's just a way of expressing solutions.
Okay, thanks. And I think that's all of our questions for today. And what can I say? I wouldn't even try to recap everything we said, because we talked about different stuff. And it was Podlodka podcast. Today, Женя, Katya, Yegor, and Bjorn Straustrup here today. Thank you very much. As I said, it was a huge honor having you today here in our studio. Thank you very much for coming.
Thank you.
And
so goodbye, everyone.
Bye-bye.
Bye-bye.